Have you ever wondered if everything we flush down the toilet is waste?
For generations, abundant water supplies have supported our way of life. However, rising global issues of diminishing safe water supplies and other finite resources have warranted the recovery of resources from wastewaters. Given the composition of wastewaters and the concentration of emerging pathogenic material that it contains, one important question to ask is, what are the health impacts associated with resource recovery from wastewater?
The idea of recovering resources, particularly nutrients, from wastewater is not a new one. Nature does it naturally. Organic matter comprised of animal waste and decomposing organisms acts as the base of the food web. Furthermore, historically, people have used night soil or human manure as fertilizer in agriculture as early as 400 BC in ancient Attica. The use of night soil was also very common in places like India, China, Singapore, Hong Kong, the UK, and Japan, and continues to be so in varying degrees throughout the world today. Given the growing need for resource recovery from wastewater, engineers are beginning to champion the development of new design paradigms that emphasize sustainable and effective resource recovery from wastewater. With this shift from wastewater treatment facilities to wastewater reclamation facilities, and knowing that many microbial and chemical contaminants exist in wastewater, one important question is, can we make resource recovery safe? Presently, norovirus, rotavirus, salmonella, campylobacter, both bacteria, ascaris, helminth, cryptosporidium, a unicellular parasite, are among the most prevalent and widespread known human and zoonotic pathogens found in wastewater. However, the emergence of additional pathogens such as microsporidia, mycobacteria, and coronaviruses such as SARS are of growing concern due to their presence and high concentration at times in wastewater. The transmission of this diverse group of pathogens occurs through various routes, and they can cause a variety of symptoms, from gastrointestinal illness to respiratory infections. Currently, routine measurements of fecal indicator bacteria are used as surrogates to represent the possible presence of actual pathogens in wastewater, or treated wastewater. Given the biological differences among the different types of pathogens, these indicators do not always adequately reflect pathogen presence. The lack of an adequate and easy indicator presents a challenge to ensuring safe resource recovery.
We're really using technology that's 100 years old, measuring targets like fecal coliforms, for example, by culture. And so we really need to step up the game and be able to really do some risk assessment and really understand and really be able to present to people, hopefully, that this water that we're producing or this resource that we're recovering does have a very low risk.
Using actual measurements for reference pathogens to calculate risk based upon human interaction with the recovered resource is an important tool to minimize human infections. Remember, human exposure is very different when reclaimed water is used for industrial purposes versus drinking water. In addition to the presence of human pathogens, wastewater also contains a variety of chemical contaminants. Of particular concern are pharmaceuticals that are found in wastewater due to their direct disposal in human excretion. For example, the presence of antibiotics in wastewater is increasing bacterial exposure and consequently leading to increased antibiotic resistance. The implications of increased antibiotic resistance among bacteria in wastewater and the environment are unknown. However, researchers suspect that this will inevitably increase the incidence of antibiotic resistance among bacterial pathogens. Another example of a pharmaceutical of concern found in treated and untreated wastewater are birth control pills. While there seems to be limited concern in terms of human health, scientists have shown that these chemicals demasculinize fish populations, threatening their continued existence in aquatic systems exposed to treated effluent. In order to ensure safe resource recovery from wastewater, continued research is needed to better understand the prevalence of chemical contaminants in treated and untreated wastewater, as well as their possible effects on human and environmental health.
In developing countries, the limited physical resources to treat water, socioeconomic situation, and the context of urbanization create the conditions for unplanned and uncontrolled wastewater use. As a consequence of the high global food demand, it is not surprising that the biggest use of wastewater, treated or not, is agriculture. The availability of wastewater and high nutrient content allows for increased agricultural productivity, and the related food supply gains grants farmers a more reliable livelihood with indirect benefits of using the income for education and improving health conditions. Biogas digesters are a form of waste treatment technology that produces biogas and a nutrient-rich slurry that can be used as fertilizer. The use of biogas as a cooking fuel source reduces the need to combust biomass, which is attributed to the cause of upper respiratory diseases.
As we all know, there's poop everywhere. You can't go wrong. You can't not have the fuel to fuel the system. You can see the plight of the two different kind of families. The one with the biogas, basically, they light up their Jiko in the morning just by the strike of a match or the flicker of the switch. They've got their tea done in 5 minutes. They've got their lunch done in another 10 minutes. They've got their dinner done in a very short time. There's none of that collecting firewood, all of those hassles associated with firewood and charcoal. On top of that, it's an absolutely clean energy, so there's no disease related to inhalation.
No, I'm not you. I'm curing you. What do you do when you have a stomachache? Take medicine? If you're infected with Clostridium difficile or C. diff, then you might need to take antibiotics. However, a new study shows that it is not drugs you need, but healthy stool. Dr. Keller from University of Amsterdam treated 16 volunteers with severe diarrhea by using fecal transplants, transplanting healthy stool into a patient's body. 13 people recovered, compared with only 4 out of 13 volunteers who were treated with antibiotics. This study was published on the New England Journal of Medicine on Wednesday. This same method was also used on an elementary school kid in Hong Kong who suffered from severe diarrhea. His parents donated their stool and the child gradually recovered.
In addition to effective marketing, outreach, and education with regards to resource recovery from wastewater, it will be necessary for engineers to approach the design process in an innovative way. This figure from Guest et al. Displays the suggested design framework to achieve sustainable resource recovery. It highlights the importance of continued stakeholder participation in the design and planning processes. In addition to the collaborative efforts by engineers and scientists to create safe technologies for resource recovery, it is essential that they work alongside anthropologists in order to ensure that the technologies are culturally appropriate.
Social assessments are necessary and they are time-consuming because you have to understand the culture and the holistic situation in which that culture exists. And the second point is, ideally they take a long time, but they don't have to. So you can do a rapid assessment, and a rapid assessment can be done by a team of specialists in collaboration with local community people. So there are ways to shorten a social assessment, but you don't want to skip a social assessment, because if you do, then the intervention or the model or the design may look gorgeous on paper, but won't be accepted by the community, or if it is accepted by the community, won't be sustained by the community.
And engineers engineers have a tool belt, and that tool belt, for a lot of them, has one thing in it, and that's technology. So engineers need to expand the number of tools they have in the tool belt, right? So one tool could be policy, one tool could be education, one tool could be decentralization. And so this idea of if you understand geographical context, if you understand cultural context, if you understand how gender influences some use of technology, you've expanded your toolkit. And if you have an expanded toolkit, you should be able to design and implement safe and effective resource recovery systems.
Just as nature has always recycled and reused organic matter, we will inevitably directly or indirectly recover resources from wastewater. The question is, will we maximize resource recovery while balancing the need to preserve human and environmental health?